What's up, everybody? This is Eddie, and welcome to Flex and Friends, a live video series where we keep you up to date on all the latest tips, tricks, and trends within the machining industry so you can stay hip and keep on making chips. So hey, thank you so much for joining us today. And remember, this is a live and interactive stream, so we not only encourage, but we anticipate each and every one of you to leave any questions or comments that you may have in our comment section. But remember, you do need to be logged into your YouTube account in order to take part in the fun today. So get logged in, join in the fun, and you never know, we may be able to take your comment, lift it up, put it on the screen, and answer it in real time. Also, following our demo today, make sure you head on over to Flex Machine Tools YouTube page. I need you to hit that subscribe button, hit that bell to turn on the notifications so we can keep you in the loop with all the amazing content. And last but certainly not least, give us a huge thumbs up. So again, thank you so much for joining us today. We have a really cool demo. We're going to be starting here today at our FlexCNC 2004 G Series long bed vertical machining center, and all the magic happening at the spindle is going to be backed by the amazing tool provided by our dear friends at Allied. And then we're going to take those parts that we work on the machine and bring them over to a GHM60 and tap those holes in real time. We're excited to get this rocking and rolling with everything that we have going on today. So as always, you know I never travel alone. I've got my good friends with me. So let's bring on our very first guest, our good friend and veteran of the Flex and Friends series, Kevin from Allied. Kevin, hey, thank you so much for joining us. How you doing today, man?
I'm doing fine. I appreciate you guys having us here again. So
yeah, always a pleasure, man. Yeah. Absolutely. Hey, why don't you tell us a little bit about you and what you do for Allied?
I'm a field sales engineer for Allied. Basically, what I do is have a territory that I cover, and we work with the distribution in that territory and go into end users and help them with their hole making applications or any issues they might be having. So.
Well, right on, right on. Well, thank you so much for joining us today and being one of our industry leading experts. And our second guest today is the wildly popular, really one of the most genuine and authentic voices here in modern machining, with over 119 followers, 119,000 followers on Instagram, as well as over 474,000 subscribers on YouTube. So you know he's putting out some amazing content. Let's bring in our good friend, Abom79. Abom, man, always a pleasure collaborating and working with you. Thank you for bringing that shining, bright, beautiful face onto our stream today. How you doing, man?
I'm doing great, man. Thanks for having me on.
Yeah, absolutely, absolutely. So, hey, man, for those who may not be familiar, which I'm sure it's not a ton of people, tell us a little bit about Abom79, what you got going on, and what type of content you release to the industry.
Well, I'm a manual machinist, and I have my little humble machine shop here at the house. And I get into a lot of different content creation, but primarily work on job shop jobs, you know, that involve manual machining and industrial repair. And I like to capture a lot of that and share it both on my YouTube channel and over on my Instagram page.
Right on, man. So as you can see here, lots of amazing, relevant content that we'll be diving into here in the near future. So following, make sure you check out those socials as well. But with that being said, I know you didn't come here to listen to me talk. Let's see a little bit of spindle running here. So as always, we have our master of machines, my partner in crime, Aaron. What's going on, big guy?
How's it going, man?
Hey, it is well. You ready to make some chips today?
Absolutely. We got a great tool from Allied that we're going to showcase here that we drilled some holes in a block of 1018 steel. To send over to Abom there to do some tapping on. So we're going to have some fun today.
There we go. Well, hey, man, without further ado, let's get started. Where are we going, man?
Yeah, so Kevin, if you want to kind of talk about the drill that we're going to use here, we got the Vortex IC drill. And kind of give a little insight on why we chose this particular drill as opposed to a couple of these others that we have here on the table.
Yeah, absolutely. The Vortex drill that we're running today, they're shown on the screen here. This is our IC drill. It's a single effective cutting tool, which means we have a central insert, and offset we have a periphery insert. You can see on the end of it there. This tool works really well if you're in a lower horsepower type machine. We've got a couple of other drills that they have sitting on the bench there. One of them's our TA, and the other one is our Apex tool. They're both great tools, but in this application, both of them tools would take more horsepower and torque than what the Vortex drill is going to take. We're going to be running today at 800 surface feet and 3.5 thou per rev with the Vortex, which calculates to about 12 horsepower and 36 foot-pounds of torque. Just for comparison, if we were to run that TA in say like a carbide application, we would be running a much lower surface footage at like 310, but we'd be running like 17 thou per rev, which would do a fantastic job. The issue is it would take almost 18 horsepower and 140 foot-pounds of torque to run. So if you got a larger machine and can optimize the TA, it would work really well. The same with the Apex, which is right next to it. That one would run a little higher surface footage than the TA, less than the Vortex. It would be like 650 surface feet at about an 8 thousandths per rev. That one would take quite a bit more horsepower at 28 horse, but it would only take about 105 foot-pounds of torque because it is running a lower chip load than like a TA would. So the Vortex was picked for this application because we've got 18 horsepower available on this machine, and in high gear, we've got 92 foot-pounds of torque. So the Vortex just is a perfect fit for this application. That's basically why we picked it for this demo today.
When we went to drill the holes, there was a little bit of kind of a whistle based on the material that we're running. Now, can you kind of explain maybe a comparison with the material to the geometry of the insert that we're running, why we were getting that noise? Because what we were going to have to do is just run some footage of the video of the drill running. That way, we can still hear you talking. So what's the difference between the material and the geometry of the inserts as to what kind of noise we're going to get off of this drill?
Sure. An IC drill, because 1018 is fairly soft. When you get into soft materials with an IC drill like this, where you're single effective, a single effective tool is not an inherently balanced tool like a double effective tool would be on, say, a TA. So with that imbalance, it does pick up a little bit of harmonics. It's not like it's going to be crazy loud, but you do typically get a little bit of a whistle when you're running like 1018 materials. You get it in a stainless application. You get into some harder materials like a 4140, 4150, 4340s, that kind of material. They run really quiet in those applications just because it is a little bit harder material and it doesn't tend to pick up that whistle like it does in this 1018.
Sure. Now, something else about this drill. This is going to be a hole that's for a 2-inch tap that we're going to showcase here in a little bit. But we put this drill inside a sleeve, and it was allowing us to adjust the diameter of the tool. Can you speak a little bit on the sleeve that we used?
Yeah, we have, this is actually a 45 millimeter drill that we're running. So it's a 1.771 diameter, nominal diameter. We needed to create a 1.782 diameter for your 2-inch tap. So we've got an eccentric sleeve that we put up inside the holder, and then the drill goes inside that eccentric sleeve. And basically, you just dial that sleeve to the diameter. We increase the diameter 11 thousandths. The sleeve that we're using today is capable of taking that nominal size and going about 24 thousandths over nominal to the plus side and 8 thousandths to the minus. So that's the adjustment range that we could get with that sleeve with this drill in this setup. That same sleeve that we're using in this machining center setup can also be used in a lathe application. In a lathe application, the sleeve is not meant to adjust the diameter of the drill. It's in those applications, it's meant to compensate for a misalignment of the drill, where lathes can be off center, in the plus or minus direction, where it would put that center insert above center or center insert too far below. That same eccentric sleeve could dial that out and put that center insert right on the center line where it needs to be. So it's a really nice little tool that we have for this drill. Not always needed. Probably only needed maybe 5 or 10% of the time, but it's nice to have when we do need it.
Yeah, obviously a tough tool in itself that can you really show a lot of versatility, but really from the machinist standpoint and someone considering purchasing a tool like this, can you touch a little bit upon the ROI that we should be able to expect when running something like this?
Yeah, and an IC drill like this, because there's two pockets in that IC drill. That insert can be taken out from the outer pocket and indexed to the inboard pocket. So you can utilize all four edges on that insert. Two of the edges get used on the inboard, two of the edges get used on the outboard. And because of that, you're using a fairly inexpensive insert and you're getting four edges out of it. So cost per hole on an indexable drill is typically very low. You're down into the cents per hole. I mean, it might be, 2 or 3 cents per hole in certain materials, versus some of the other drills that would be just a little bit more expensive to run maybe. IC drills tend to cost less.
No, noted. And obviously with applications like we had just seen here, how important of a role does coolant play, and what are some of your preferences when it comes to that?
It plays a huge role, as big a role as anything, actually. Preference is, if I had a preference, I'd have 1,000 PSI of through coolant in every application, but that's not realistic. So an IC drill, obviously we want to have through coolant if possible. I've seen it run anywhere from 100 PSI up to 1,000 PSI. We can run, if it's not a very deep hole, say a 2 times, maybe 3 times might be pushing it. You could do a flood coolant application, where you're just spraying from the outside. And in some structural applications, because you guys sell a flex beam also, we could run this drill on your flex beam with just a mist coolant through the tool. So because we're going really shallow in a structural application like that, typically those are only 3/8 to maybe 3/4 of an inch or something thick on a structural. So the mist coolant would work fine in those applications too. So it's a pretty forgiving tool as far as the coolant goes.
Now, very good. And then kind of before we move on, you briefly touched upon it before, but just to make sure everybody gets a quick recap, what are some of the ideal applications, AKA or slash, who specifically needs this type of tool in their shop?
Who needs it? Basically, if you're trying to put like a large hole in a smaller horsepower machine, and you can't push a double effective, that's a good application for an IC drill. Other good applications would be if you've got like an angled surface that you're entering on. A lot of drills need to have that center point. If it's a double effective tool, that center point needs to touch the part first. If you're entering on, say, a 30-degree angle, an IC drill can enter on an uneven angle like that very well. Can do like a half a hole. So if you've got a hole to put in down the side of your part, you could offset this tool, run it right down the edge of the part, and put a half a hole in. You can plunge drill with this tool too. So if you've got a cavity that you need to machine out, you could take this Vortex and you could just keep, plunging a hole, step over half a hole, plunge a hole, step over, plunge a hole, and rough a lot of material out of a cavity. So there's several different applications for an IC drill like this.
Yeah, and there sounds like it for sure. And obviously we saw this application here. And for all of our viewers today, due to the amount of noise sometimes that this can create, we wanted to make sure that we could do our talking back and forth. We did show obviously that high resolution B-roll, but following our demo, we're actually going to run this live with full sound for all you machinists out there who really want to see this raw, real live footage, as well as hearing the sounds of these chips being made. So with that being said, is there anything else we have to do with this specific demo or featuring this tool, Aaron?
No, I don't think so. The drills, go ahead, Kevin.
Yeah, I just want to say something about the noise there. It's not like, I just want to reiterate, it's not like a really loud noise, but the noise is enough that it does affect our microphones, so we can't talk back and forth while the drill's running. That's why they're kind of running the tool the way it is right now. So, yeah.
Yeah, no, I think the part itself is dialed in very nice. The tool with the sleeve, Kevin was able to help me out get that dialed in. running very consistently. So I think we're ready to move on to get these things tapped.
Yeah, it's awesome. So we started off at our FlexCNC vertical machining center using our allied tooling and just drilled the heck out of these holes, but we're not done just yet. We then took those specific parts, we sent them to our good friend Abom79, who uses GHM60, our biggest, baddest tapping arm. And I won't go into too much detail, we'll let him speak it. So, hey Adam, let's bring you on here. And before we get rolling into that specific demo portion, really talk to us about how you tapped before you had the FlexArm in your shop.
Well, being a manual machinist like I am, I generally had to rely on the machines at hand, which would have been, a vertical mill, horizontal boring mill, and anytime I could, I would install the tap, in the spindle of a mill and just power tap it that way, using the spindle, floating spindle to do the tap. But you're always limited on what each machine can handle, based off the horsepower and whether, the tap itself, you can get it fitted in there with an adapter. So anything that I couldn't get in the spindle to hold it, I would always have to tap it by hand. So old school, I'd have a tap wrench on there, have a center coming down, that's being held in the spindle, and just strong arm it with both arms. And just manually tap it. And believe me, I've had to do a lot of large holes that way, with big taps, especially some coarse threads.
Right, I can imagine. My forearms hurt just hearing you tell that story, man. That's gnarly. That's gnarly.
Made a lot of good video, though.
There we go. And hey, looks like we got a shout out here. Adam Carl Johnson. Hey, thanks for commenting. He says, good to see Adam. Hello from the UK. Look at getting some UK love there, Abom.
That's awesome. Hey, Carl, what's up, man?
That's amazing. Hey, that's what it's all about here. So as we kind of keep rolling, so really when it comes to this specific application, how do you feel the FlexArm performed? And we'll show some footage here in a second, but before we do, how do you think it performed, man?
I'm really happy with the performance of the machine. The GHM60 is a hydraulic operated machine, so you've got that big hydraulic power unit, and that was first time running a 2-inch tap with that sucker, and I think it did awesome. I was really concerned that it was going to maybe try to stall the machine, but it had plenty of power to push that tap down in that hole, and it did great.
Well, there we go. That's what we like to hear. Now, we've been talking about it, and let's go be about it. Isaac, you want to pull up that specific B-roll, and the Abom, give us a play-by-play, man.
Okay, well, here we go. I'm using my dark sulfur-based cutting oil here to keep it lubricated, but you can see I'm running it pretty low. I think I was around 25 RPM on this, so I wanted to make sure that I wasn't running it too fast, but it engaged immediately and started pulling itself down in that hole, and did just a great job. So I'm just continuing to keep the tap well lubed with that dark cutting oil, and of course having to pull my hand back every now and then to let those chips get out of the way. But that's part of the fun watching those spiral fluted taps like that, is seeing that chip come up out of the tap like it is. And I don't remember if we had mentioned it. Those are 4-inch. Y'all drilled those 4 inches deep, so we're taking that tap all the way to the bottom, and I'm just going to hold that thing until the machine stops and clutches out, which is part of the beauty of the FlexArm. That tap holder for that thing will clutch whenever it hits the bottom of the hole, and you don't have to worry about breaking a tap or breaking the machine. And we should be getting pretty close here to the bottom. You can see those beautiful chips coming out of that hole. There we go. So we just hit bottom there, and so I'm just going to reverse it. And I think on the reverse, so you can adjust the speed, forward and reverse, so whatever speed you want. I think I had it up around 40 to 50 RPM coming out of there.
Now, what I think is great is you did that all, looks like just with one hand. Like you're able to, obviously use your lubrication with one hand. And really, you tapped a 2-inch hole one hand, which I think is pretty gangster. I don't know about you.
Yeah, that was pretty cool. That's the first time I got to experience that, letting a machine, the FlexArm actually tap a 2-inch hole like that. So that was a lot of fun. And yeah, it's just one-handed operation. You push the trigger, and of course the FlexArm has the mist coolant capability set up on it. I'm not running that. I'm just using my cutting oil, just personal preference there.
Sure. Yeah, there are definitely many ways to go about it, and we're glad that you found your way. But at the end of the day, one-handed tapped a 2-inch hole with ease. So really, as a true OG machinist, Abom, why would somebody even consider using a FlexArm?
Well, I think it's going to be a great machine for a job shop such as mine. If you've got a lot of parts like this that you need to, especially these large parts that you got to run the large tap in there, go to the machine. You can easily use a drill and drill the holes, and then go over to your setup with the FlexArm and just keep running that tap down in their hole and get it done. So it is a really good productive tool to use if you've got a lot of holes to tap. Where if you take somebody like me that's used to running a manual milling machine, you have to drill the hole, step the table down, drill another hole. You have to keep doing that. Where instead of doing that, you can take your part over to the FlexArm and just line up the tap on each hole and quickly tap it and just run right through your part. So it is definitely a time saver.
Man, then that's amazing feedback, and we appreciate you being open-minded to really tackling this tough tapping application. Don't try to say that 5 times fast, but no, that's amazing. We really appreciate all of your insight and then for bringing that expertise to our stream. So again, we started on our FlexCNC machine. We drilled with our Allied tooling, sent it off to Abom. He absolutely tackled it. And then we got our good friend Timothy Forney. Hey, appreciate it. He says FlexArms are a huge time saver, great chips. What more do we need then? What more do we need to say, man? That's just reassurance from all different angles, man. So now that we get to see it live, we get to hear all this great feedback. We appreciate you all for it. Steve says, another Abom79 fan here, admiring this cool machinery. Man, it never stops. We love the love, man. Valentine's Day is just around the corner, man. We love the love. That's good stuff. That's good stuff. So, man, well, with that being said, we've made our chips. We took those drill blocks, brought them over to our GHM60 tapping arm, absolutely slayed through, made some amazing threading. And as we kind of finalize our demonstration for today, we're going to bring in our experts one last time, get some final comments on what we have going on, and then we'll put a pretty red bow and make sure we're going to end this by running that drill application live. So let's bring back Kevin from Allied. So Kevin, hey, thank you so much again for joining us today. Can you tell us maybe a little last bit of feedback on the drill we saw, and then where can we get more info on Allied?
Sure. Yeah. Again, that was our Vortex drill. We're running it in 1018. So here we are using what we call our high rake inserts. We do have different inserts for different applications. We have, our standard geometry, which is good for like carbon steels, most steel applications. The high rakes for the softer materials. We do have a low rake for hardened materials, and cast iron geometries and non-ferrous geometries available for it too. So we can dial that drill in, pretty much to any application. Yeah, I mean.
Very nice, very nice. So, hey, for those who are looking to get more information from Allied, where can we go to look?
Oh, I'm sorry. Yeah, you can go to our website at alliedmachine.com. There would be a phone number there. You can call us. You can get a hold of me. I can help. We have a huge support staff at Allied that can help. We have a large engineering applications department that can help, solve almost any issues. Everything we do at Allied is hole making. That is all we concentrate on, and we feel like we're the best at doing it. So we can do anything from rough drilling to, we do boring. We have burnishing tools, reamers, so anything from rough drilling to finishing the holes. So, and everything in between.
There you go. I love the confidence, love your expertise, and we appreciate you obviously joining us once more for yet another amazing demo here. So thank you so much, Kevin.
Yeah,
and then next, we're going to bring back Abom79. Get back in here, big guy. All right. Well, hey, man. So there's plenty of people out there. Obviously, you have a huge fan base. But for those who are looking to get, or I guess dive more into Abom79's content, where do we look? Where are we going? What do you have coming up next for us?
Well, if you guys are interested in seeing more footage of that 2-inch tap, I'll actually have the full edited video that I'm going to release this Saturday. I have a weekly video called Saturday Night Special. So this coming Saturday, I'll have all the video that I took of tapping those blocks with that 2-inch tap edited and ready to publish there for everybody to see. So, obviously go over to YouTube and search for my channel, Abom79. You can find me there. I've got lots of videos out there that you can watch with a lot of different machining content, a lot of general job shop applications and industrial repair. And then you can go over and find me on Instagram as well, Abom79. I like to share photos and videos there, kind of on the daily occurrence of different things that I'm getting into.
There we go. Looks like Bill. Bill, hey, thanks for joining us. Thanks for your comment here. Check out Abom79's SNS 329 production tapping 180 tie rod. Look at that. There we go.
That was a production job I was doing. Hey, Bill, what's up, man? That was a set of tie rods. I had to chase the threads in a bunch of those guys, and really helped out that company there with that batch of tie rods.
Yep, there's continuous content. And as always, we're super, super appreciative of you joining us. So again, big shout out to Kevin at Allied. Big shout out to Abom79. You guys are both gangsters, and we appreciate you bringing your industry relevance to our episode today. So make sure following our episode, and when we close things out, you head on over, you check out Allied's website, check out all their socials, and to see the full length video of Abom79 tapping and tackling that 2-inch hole, head on over to his YouTube page and all of his socials. He's very active, posts a lot of amazing content, and as many of you are familiar, he keeps it rolling. And check out that episode that will be featuring on Saturday night. So hey, as well, make sure you hit that subscribe button, hit that bell to turn on the notifications so we can keep you in the loop with all the amazing content that we'll be releasing. Last but certainly not least, give us a huge thumbs up. So thank you for our experts. Thank you, viewers. Thank you, Aaron, for running our machine today. You're an absolute expert, and we appreciate that. So all of you, thank you for joining us. You all stay awesome, stay flexing. We'll see you next time. And for those of you who are looking to watch this drill run live, here we go.